Well, the most staunch people remain in the hall. Maybe some other will follow you. We're expecting more people to arrive. So it's a pity we have a lot of human losses, a lot of material losses, which means that we have to take into account seismic activities. In some regions of Russia and the neighboring countries, such calculations are mandatory. I lived in Sochi, and seismic is up to zone 9. And before showing us how to do it in sophistic, let us recall what is an earthquake, how do we take it into account, what kind of seismic analysis is available for different buildings. Special attention we have to pay to compliance to the local Russian norms and how they are implemented in sophistics. So theoretical data. Earthquakes take place deep under the Earth's surface, and there are two groups of characteristics to measure them. The first one is the intensiveness in the hotbed of the earthquake by M magnitude or Richter scale. The other one is earthquake on the Earth's surface. It's the zone characteristic, and the correlation between them can be seen on the street, the magnitude and the zone scale. As you can see, there are deep underground waves, longitudinal and latitudinal, and they provide oscillations. When deep waves reflect from the Earth's surface, we have reflected waves as well. In Russia, we use the 12 scale seismic, 12-point seismic scale. We also take into account the accelerations on the ground. And the limit is zone 9. Up to 9, no structure will sustain, any structure will collapse. And of course, there are some requirements to seismic calculations. So we have to use two situations. The seismic loads for the projected earthquake and the maximum possible earthquake. And such calculations should be carried out with the help of instrumental or synthetic oscillograms. For buildings with a simple design, we can use calculations based on console-based dynamic model. For the buildings with a complex design, we have to take into account special calculation dynamic models of the buildings. Accordingly, we have two methods of seismic calculation: the linear spectral method, which is used for simple design buildings and small buildings, and the direct dynamic task method for more complex buildings and for taller buildings. These two methods are supported by sophistics. So acceleration and time can be shown in this graph. We have so-called seismogram, according to which Then you can build the accelerogram and define the effect, the external effect of the earthquake. So normalized and compared with the regulators' norms. For example, the response range shown in our Russian documents is shown on the left, on your right, below the same chart in Sophistic. The seismic load in the Russian norms is defined according to this formula with indices of the purpose of the building, acceptable damage, mass, acceleration, and other parameters. Sophistic uses almost the same formula. I'll show it to you. And to begin with, I would like to show you the implementation of linear spectral method in Sophistic. We have a separate dialogue for that. It's called seismic calculation, in Russian at least. As everything in Sophistic, we can do it in CAD-IMP language of programming. You are free to choose any of the two. In CAD-IMP, you will have more options to manipulate initial data and get appropriate results. The dialog window is simpler, more convenient, user-friendly, but it's more limited as usual. The dialog task is added from SSD window. We open the list of tasks, choose seismic or earthquake if it's English language interface, and see what it contains. It consists of several tabs which describes certain steps. Data entry to calculate frequencies of oscillations, compensating appliances, additional masses, vectors, ranges, and results. Let us have a look at each of the tabs. First, the first one is the number of forms of oscillations, the number of entry, the method of calculations, the calculation type ACE and DINA, or DINA. ACE is simpler. If you need extended data, use DINA, please, and the parameters for calculator. Then the next tab is damping, or damping is up to 5%. Attenuation by relay. Frequency must be added, maximum, minimum, additional mass, additional load rather, distributed to active masses. We define the type of mass matrices, and now the influence directions. In which direction are we going to calculate? In this window, we have certain limitations. Later on, I'll tell you more about it, how to bypass them. We have to define the range of influence. It may be the same for all directions, or it may be different by X, Y, and Z axes. Then the response range, type of range. You can have several types. We define them initially at the initial step. If we take into account horizontal range only, if it's one thing. If you have 3 axes, then you must have initial data for each of the 3, and then we choose the norm, including the Russian norms. They are available. Separately, we have a tab for vertical and horizontal factors, additional indices with formulas. Everything is available. And in extended parameters, on your right, below, you can indicate periods of oscillations and other things, which, if necessary, and the results, the type of different oscillation types, then we have specific figures demonstrating reaction of your elements. This is the simplest dialogue available. What do we do in direct dynamic task? That is a benefit of Sophistic, its advantage in comparison to other tools. Dynamic task means that you can describe a specific function of external influence. For example, accelerogram, seismogram, or any other dependency. And then you can see how your building is going to be deformed under this influence. As an example, we have this kind of initial data in a table, an accelerograph for you, accelerations graph, accelerations chart. It is programmed in TEDI at Kadip language. Then we transform it into loads in the soft load module, and then step by step we calculate the deforming of the object. It's a detailed analysis based on a specific chart of accelerations. When we analyzed this module, learned it, we talked to designers who calculated seismic factors in Sophistic and found several problems, which I believe we have to discuss. The more so that Sophistic experts are present here, and that will accelerate elimination of the problems. The first problem is like this. In the last version of Sophistic 2016, calculation is based on SNP and not SP. Although they are similar, there are some differences. One difference is in the formula of calculations. The indices are a bit different. There is a solution, though. If in your tab of response, for instance, you enter your parameters, you can do it yourself, manually, calculate the parameters, not just pick them up from the list, but enter them manually. This is one way out. Or in Kadimp, you can program all that. One more problem. According to the current norms for complex design buildings, you have to take into account the most dangerous buildings or its elements. they will not necessarily coincide with X, Y, or Z axes. And what is the solution then? The simplest one is to use CAD-INP again. We take a chart and transform it with help of one instruction into text. In SSD, we press a button, transform to text, and then we can edit the text and enter appropriate parameters. Enter an angle, for instance. This is the simplest way to avoid the problem. And to conclude, we have to say that Sophistic gives you a wide range of opportunities in terms of seismic calculations, almost unlimited capabilities if you use CAD-INP. The problems we mentioned can be solved through CAD-INP, but I believe the developers will do something else. They will cooperate with us, and in a dialogue mode, in a graphical user interface, we shall be able to solve that problem as well in the near future. And I'm going to show you the objects where seismic parameters were calculated in Sophistic. The objects from Apex projects. If you have any questions, I'm going to answer them. Thank you, Alexander. So far, with the Russian norms, I have a proposal. Now we're going to have the most interesting part of the conference. Let us ask one last question and then ask the questions to all the panelists. Yes, please. Please tell me, did I get you right, that Sophistic doesn't take into account the reflected oscillations? Reflected oscillations, so we have such a notion. You don't have all the oscillations, the model masses, so to say. Yes, you can enter the number of oscillation forms at the very beginning. So there is a special task in dynamic model where you can select the right number. 100, 200, yes, the limit is about 90 to 95. But first, define the number of forms of oscillations and then use all the variety. But there is also you have to take into account the non-found oscillations, the oscillations we don't know about. I haven't seen that before. And the second question, if you like. Well, I have a proposal. Ask you a very little question. Dynamics in time. We have only 3 components, 3 oscillograms. Or can we have 6? 3. Thank you.